Hey guys, and welcome to a new video in this computer vision tutorial. In this video here, we're going to talk about histograms. So first of all, we're going to shortly cover what histograms are and how they work. And then we're going to talk about some of the applications of histograms and what we can use them for. Like say you have a problem or like a project where you want to segmentate out or fill out a certain color, then you can actually use histograms to detect what color, what specific color that you're operating with and that you want to segmentate out. For example, we had a project where we have a ball or like an object that we're tracking around with a certain color, then we can actually use histograms to find that specific color that we can then segmentate out from the image and do some different kind of operations with that. But first of all, remember to join the Discord server down here. I linked it to it in the description, and then you can join the community here where we talk about some different kind of stuff within computer vision, artificial intelligence, deep learning, and a lot of other different kind of stuff. And if you have a project that you're doing and you have some problems, like you can go ask your questions in there, or if you just want to find inspiration for other projects that you can do on your own, make sure to go join that channel and join the community. So we'll jump into the first slide here where we're going to talk about the one-dimensional histograms first. So a histogram is where we have the intensity of the image pixels down here on the x-axis, and then the number of pixels up here on the y-axis. So when we are talking about 1D histograms, we will only get global information about the image, or like global information about what is going on in the image. So we can't really detect what different types of features and elements are there in the image. We can only have some information about the pixel intensities in the image with these histograms here. So histograms are not unique to a specific image or to specific objects and stuff like that, because we don't have this information here. We only have the information about the intensities of the different pixels that we have in our image, and then we can see how the intensities are distributed in our image. So it could be, for example, used for a classification if you want to classify some specific color or some specific colors in an image. Then we can actually use histograms to do that by using by looking at the intensity of the different kind of pixels and then do classification from that. So down here we have an image here which is a grayscale image, so we'll only have one dimension, so we only have values between 0 and 255. And then we go through the whole image here, and then we check for the intensity for each of those pixels here. So we have some different kind of bins for all the pixel values that we have in our image. And then for each of those bins here, or for each of those pixel values from 0 to 255, we actually calculate how many pixels is in this bin here, and then we can make this histogram over here to the right, where we can see how many pixels are there with this specific intensity in the image. So over here to the right, we can see that we get a huge spike here around up here in the darker values. So we can be in the brighter values here. So we can see, for example, this value here that is spiking up here with this intensity here could be, for example, the background, because we can see that we have a lot of background here, or the sky here in the background, and then we can see this is mostly what is going on in the image here with the same intensity. So we can see that this spike here from these darker values here, which could be the roof and the garage and the ground here, and then we can see that we get a huge spike here in the intensity, which is that we can see that we have this background or this sky here in the background. So we can actually do some different kind of we get some information about what is going on in the image and how is the intensity changing, but we don't know if this is a house or if it's some other different kind of objects. So this is no global information. It is not unique, but we can use it for some different kind of things, and we can see how the intensity is in the image by using histograms. So let's now see how we can use 1D histograms in OpenCV, and at the end of the video here, I'm actually going to show you the different kind of examples here where we're going to run the code, and I'm going to show you how we can actually use the histograms, and also how we can do the histograms in OpenCV and how we can interpret the results we get from doing these histograms here in OpenCV. So first of all, here we need a matrix here where we can store the actual histogram that we're going to calculate. And then we have the size here of the histograms, which is the number of bins that we're going to put the different kind of intensities or number of pixels into. And in this case here, we have a grayscale image because we have only one 1D histogram. So we have these values between 0 and 255. And then the channel numbers here is 0 because we only have the grayscale image here. And then we also need to specify the channel range here. And the channel ranges in case we have more. And then also the number of bins here, which we just set equal to the histogram size here. So these are the default and the standard parameters that you need to specify for this CalcHist function down here in OpenCV. And then when you want to calculate the actual histogram for that image, you need to specify the image that you want to calculate the histogram from. And then we just pass these different kind of parameters here to the function here, which is the default parameters that this function here takes to actually like calculate the one-dimensional histogram. And when you run this block of code here, you will actually like get the histogram. You will get the calculations for the histograms, and then you need to like draw it on an image that I just showed you on the previous slide. So we can also do one-dimensional histograms with colors. So when we have like, for example, three channels. So in the last example, we only had one channel. So we had a grayscale image, and we just looked at intensities from 0 to 255, where 0 is black and 255 is white. So we can also do it with color histograms. So we can actually like segmentate out like each color channel in our histogram and see like the intensities for each of the RGB values in our image. So in this case here, we're going to calculate the histogram for each of the channels here in the image. So we will like split or segmentate out the red channel, the green channel, and the blue channel. And if we do this color histogram here for the same image over here, but in this case here we have a RGB image, then we can actually like see the different kind of values here for the RGB values that like number of intensities for the different RGB values here in the right histogram. So we can see that we get again some spikes here in the like the upper range of the intensities here. So we can see that this is a kind of bright image from this histogram here, and we can see that there's a lot of different kind of colors in this image here as well. And also like the differences in colors is also very great here. But we can see that we're operating with a bright image here because our a lot of the pixels here is in the upper range of the pixel intensities here. So this can be used for some other different kind of examples and purposes and stuff like that. But we're going to do this in code as well, and then we're going to talk about like what it can be used for and how it's done. So this is like how we can do color histograms in OpenCV. So it's just the same as with one channel, and we did it on the grayscale image. But in this case here, we just have this vector here of the different kind of matrices where we're going to store each channel with the BGR planes here. So we have a plane for each of the color channels. And then we're going to use this function here, split, which will just split the three channels from this image here into the BGR planes vector here. And then we just do the same thing here with the default like the parameter that we need to specify for the CalcHist here. And then down here we need to calculate the histogram for each of the channels here. So we just call this function here with all three different planes here, and then we just specify the same parameters here, and then it will actually like calculate the histogram for each channel that we have in our image. So in this case here we have three channels in our RGB image. So we're gonna also actually like convert our image to another color space, like for example HSV histograms. So we can do like hue, saturation, and value, and then we can do a histogram on each of those channels. So in this case here, we just do histogram. We just do a histogram, 1D histogram with one channel on the hue value here. So we can actually like segmentate out colors, or in this case here, we just want to see like, for example, where's the like dark pixels and where is there like brighter pixels. So over here to the right, we can see that again we get this spike here with this pixel value here, which corresponds to all like the gray pixel values that you can see over here to the left image here. So we can also do this here on like, for example, saturation or the value here. So we want to see how bright is our image in case of the value here. So if we did the histogram here on the value here, then we can see like how bright is our image, and over here to the hue, then we want to see like the different kind of like colors that we have in our image. But in this case, if we only have grayscale, but we can do this HSV histogram here for all the three channels as well, and also all the other color spaces that are provided in OpenCV. So some of the applications that we can use histograms for is actually like segmentate out a color in the image. So if you want to find a specific color, I did this application here with stereo vision in this computer vision tutorial here as well, where we have an object that we're going to track around in the image. But first of all, we need to segmentate out the color that we want to track. And in this case here, we're tracking the red color here. So we need to find the exact red color to be able to do the segmentating out and to create this mask over here to the right. And to find a specific color here in the camera, we can actually like create a histogram for this image here, and then we can go check for this red value here and like find the exact like RGB values or like the HSV values for this specific color here that we want to track, and then we can actually like create some boundaries or like some threshold values for this color here that we want to segmentate out. And then from histograms we can then create this mask over here, and then we can do operations on this mask here and track the item around or like the object around in the image frame. So if you're interested in that, you can go check that video out. It's a really cool and nice application that can be used for a lot of different kind of things. And then in that application, we're actually like tracking an object, and then we're calculating the depth from a stereo vision setup with some different kind of multi-view geometry and stuff like that. So that was a really cool project, so make sure to check that out. So we can actually also do 3D histograms. So when we're doing 3D histograms, we actually like have all of these different kind of channels that we're considering simultaneously. So we have this blue channel here, red channel, and the green channel here, and all of them are combined together. Where in one-dimensional histograms, when we did it on 3 channels, we did it on we calculated the histogram independent on each other, and we did it like individual for each of the channels. So in the 3D histograms here, like the channels are not independent, and we get a better discrimination, which comes from considering like all the channels here in the 3D histograms simultaneously. And we can also use this to like, for example, reduce quantization, because we get like we get a better discrimination, so we can actually like use the quantization of the image, so we don't need to like store that much in the memory. So we can actually like reduce it to like, for example, 6 bits or 4 bits or 2 bits to like have this quantization resolution. Another approach we can take, and another application we can use histograms for, is actually like histogram equalization. So we already talked about this here. If you have like, for example, a really dark image and we want to like have it brighter, if we want to do some detection of different kind of features in the image and we can't really see it in our dark image. So if an image has some insufficient contrast, we can actually like use histogram equalization to equalize the distribution of the intensities in the image. So we can see over here to the left, then we can, for example, have these intensities here really close to each other, and we will have a really dark image. And when we use histogram equalization, we will actually like equalize the intensities wider in the range of the intensities down here. So we like to like spread out the intensities or like the pixel values more in the image, and then we can actually like get this more brighter image here compared to this dark image over here, where we can really extract some features in it. So we evenly distribute the grayscale, so like the pixel values or the intensities in the image, we evenly distribute those over like the whole range of pixel values that we have in our image. And we normally equalize only like the grayscale and luminance values, because histogram equalization is often used just to like make your images brighter if you can detect features in the brighter like in the dark image over here to the left, for example. We can really like see the windows here and stuff like that, and over here to the right, like we get a much better view over like the windows, and it will be easier to extract those features here if that was the purpose of our application or something like that. So to actually like do this equalization here in OpenCV, we first need to like have this equalized here, where we're going to store the equalized histogram, and then we just call this function here equalize hist, and we pass in the image that we want to equalize, and then where we want to store that equalized image, and then we just call it equalize histogram here, and then it will like to like distribute the pixel intensities out in a brighter range in like all of the different kind of possible pixel intensities that we have on our image. And then we can just show the source image and the calculated equalized histogram down here. So this is the only function you need to call to actually like do this equalization here in OpenCV. So it's really easy. If you have a really dark image and you want to make it a bit brighter, then just call this function here, and you can do a lot more feature tracking and stuff like that with your image in your application. So another, the last example here I'm going to show you like what we can do with histograms is actually like comparison of histograms. So let's say that we have 2 images that we want to compare to each other, and we want to like do some, for example, classification or detection. Then we can actually like use histograms for this here. So we have an image here to the left, and we have an image here to the right, where we're going to calculate the histograms for each of those images, and then we're going to compare those histograms together to like see, for example, if it's the same house, or if it's the same ball, or some other different kind of objects that we have in our image. then we can actually like compare those by just using their histograms and the intensities in the pixel values. And we can see that this is the same house here that is in the image here, but it is taken from different views. And we can see over here to the left, like we have a bit brighter image, and we don't have like, we have more like sky here in the background, we have like more blue here, but over here to the right we have like more of the yellow or light values here. So when we're doing histogram comparison here, we can see that down here we have some different kind of metrics for our histogram comparison. So the first one here is the correlation, and we also have some other different kind of values with the chi-squared intersection, like how much these two images intersection. And then we also have some other different kind of metrics that we can use for comparison. But often we just want to find the correlation between those two images here and how strong the correlation is. So in this case here we have a correlation of 0.6. So we can see that, say that like there is some correlation between these two histograms here, but they're not really the exact same one. And if we just look at the images here, like we can say that it is the same house, but we can also say that this is not really the same image, and it has a different view, and it also has some different kind of colors in it, and there's more sky here in the background to the left, and we see more like dark ground here on the image to the right. So we can say that like the color is not the same in these images here, but like the house, the roof, like some of the lighting and also the background is still the same, so there will still be some correlation between those two histograms here. So this is another useful application and a really like nice application for actually like using histograms. And if you just like have one image with a ball where there's not so many features, like for example in this image here, then you can actually like get a really good correlation when you're just doing histogram comparison and you want to do some like for example recognition or like object detection by just using histograms, which is a really simple application. But when you have a lot of different kind of features, like the correlation will just not be that good. So we're not just in Visual Studio here, and I'm going to show you some of the code here that we can do for histograms, and also like some of the examples that I showed you in the slide, like how we can do it here in Visual Studio and OpenCV with C++. So first of all, here we're going to include OpenCV and the IOStream and vector library here, and then we're going to use the namespace CV and std here as usual, and then we're going to specify just the image path where like the different kind of images that we're going to do some operations on are stored. And then we're going to read in the image here, scale them to 500 by 500 images with this nearest interpolation here. And then we have our images that we can actually like do operations with and some different kind of extraction on. And then down here, we're just going to specify these values here that we have from the slides here. And then we're going to calculate a histogram for the first image here with the exact same function here with this CalcHist histogram here. So we have grayscale our image in this case here, and then we're going to, the example that I'm showing you here is that when we're doing the histogram comparison, so we're going to compare two histograms for the two images that I just showed you in the slides here, and then we're going to do the same exact thing here for the second histogram here down later here. But first of all, here we calculate the histogram, we create the histogram image here, and then we normalize our histogram. And then down here we have this folder here where we just draw the different kind of lines that were calculated for our histogram, so the number of like pixel intensities that we have for each bin in our histogram. And then we have done it for the first histogram here, or like for the first image, and then we do the exact same thing for the second image. And then when we're done calculating the histogram for those two grayscale images, then we can actually like go down here and call this function compare histogram here. And then we specify the different kind of like metrics that we want to like see and output to like tell like how good are these two images here correlating to each other, for example. So we're going to use this matching correlation metric here. We're just going to compare those two histograms for the two images, and then we're going to output the correlation metrics and also the other different kind of metrics here. And then we're going to show the images as well. So if I just run the program here, we can see that we get these two images up here, the first source image and the second source image. So these are the exact same images from the slides here, but now they're grayscale, and we're going to look at like the pixel intensities in the grayscale values here for these two images here, and then we're going to compare these two histograms to each other to tell like how bright are these images here, and like how are these two images here correlating to each other. So we can see that we calculate these histograms here that we also saw in the slides where we have these different kind of pixel values. So in this image here to the right, we get like to the left here, we get a high spike here in the pixel values because we have a lot of like white background and stuff like that. Where over here to the right, we have like it is more distributed over like the whole range of the pixel values here, because we have a lot of foreground here of the ground, and then we have the house and a bit less background compared to the first image here. So the distribution of our pixels here is a bit brighter, wider, but we get like a steep fall here at the end here, because we don't have like a lot of white pixel values over here to the right in the image, compared to, like, for example, in the left image here, where we have a lot of white pixel like around here in the windows, but also like in the background here to the left and the right in the sky here. So when we're doing histogram comparison of these two histograms for these images here, we get the correlation of 0.60. So there's some correlation between these two images here, but they're not exactly the same, and they're not like really the exact same pixel values, or like the brightness of these two images here is not exactly the same, but some of the values is still does still have a correlation to each other. So it can be used to, like, for example, say that these two images here is correlating a bit, but they are not exactly the same. So this is one application that we can use histograms for in OpenCV and C++, and this was just to show you the example of the images that I showed you in the slides. So the next example here I'm going to show you is like how we can equalize the histogram in OpenCV here on the image that I showed you in the slides. So first of all, here we need to have this matrix here where we can actually like store the histogram that we have equalized, so like the image of the equalized histogram. And then we're going to call this function here, which just takes in two parameters. So it takes in the image that we want to equalize, and then we need to specify the output here where we want to store the equalized histogram image. And then we're just going to show these two images here together. So if we run the program here, we can see that we have this really dark image here to the left. And then when we actually like use histogram equalization, we get this brighter image over here to the right, because we're distributing the pixel values, or like the pixel intensities, more out in like the wider range of the pixel intensities. So this is another application of what we can use histograms for, and these are just the exact same things that I showed you in the slides. But this is just to like show you how to do it in code, and also I'll also put the code in my GitHub, and I'll link to it down in the description as well. So if you want to do some of these different kind of stuff here in your applications and use them for that, go check that code out and just feel free to use it. So the last example here I'm going to show you in the code here is the actual like 1D histogram of the three different kind of BGR channels that we have in our image. So first of all, here we have this vector here where we're going to store the BGR planes, so the individual BGR planes for the image, and then we're going to use the function here split, which will just like split the different channels in the image into these BGR planes vector here of these matrices here. So we're going to store it in that, or else we're just going to set up these different default parameters here that we already did in the slides, and also previous examples here in the code. And then we're going to calculate the histogram for each of those individual planes here. So we both have the B and the G and the R plane, and we're going to calculate the histogram for each of those channels independently. And then we're going to, down here, we're going to have this hist image here. We're just going to store like the histogram image, and so we can actually like show the three individual channels. And to be able to do that, we need to normalize the three histograms for each of the channels here. So we just call this a normalize function here from the OpenCV library, and we need to specify the histogram that we want to normalize, and also like how we want to normalize it, and some different kind of parameters here. And all of these are just default parameters from the OpenCV function. So you can just specify those here, and then it will normalize the histogram for you, and then you can actually like show what's going on in the histogram, which is what we do here down here in the for loop. So we're just going to draw lines here for all the different kind of bins, or like all the pixel values and the number of pixel values for each individual pixel intensity in our histogram. And then after we've done that, we can actually just show the source image and also the histogram image that we've calculated for all the three different kind of channels we have in our image. So if we run the program here, we can see that we just get this house image up here again, where we have a lot of different kind of colors. And over here to the right, we have our calculated histogram here, where we can see like the pixel intensities for all the independent channels here in the image for both the B and the G and the R plane. So, and then we can use this information here to extract like what type of different kind of like channel values are there both in the BGR, and we can see like what colors is actually like in our image, and then we can use this to do actually like segmentating out colors in a project where we're going to track a specific color in the image, for example. So we can also use this for HSV color space. So if we first converted our image to the HSV color space, and then we did this three-channel histogram here, then we can actually like find the specific value for the hue, the specific hue value, and then we can actually like filter out or segmentate out that hue value from our images, and so we can find the mask, and then we can like track that item in the image that has a specific color. So that's pretty much it for this video here, guys. I've showed you like how we can use histograms in OpenCV, and I also went over like how histograms works and some different kind of applications with histogram equalization and histogram comparison, and also how we can use it for segmentating out and finding what different kind of colors that we have in our image, and also what intensity does those colors have in our image. So thank you guys for watching this video, and remember to hit the subscribe button and bell notification under the video, and also like this video here if you like the content and you want more in the future, because it just really helps me and the YouTube channel out in a massive way. I'm currently also doing a deep learning tutorial and with neural networks, where we're going to create our own neural networks. We're going to talk about how neural networks work from the beginning, and we're going over the basic stuff. And then we're going to actually like create our own neural networks, do some training on the neural network on data that we have created by ourselves. And then we're going to do actual predictions with our trained and created neural network on data that it hasn't seen before. And then we're going to evaluate that and see how a neural network is training epoch per epoch. So if you're interested in neural networks, and we're going to combine it with computer vision as well later on, I'll link to a tutorial up here and you can go check that out, or else I'll just see you in the next video, guys. Bye for now.